everyone. Welcome once again to another Power BI related tutorial by Slidescope. In this part, you are going to learn about the decomposition tree visual in Power BI. So, we have also explained the steps here, but the decomposition tree is a Power BI visual that allows you to break down data hierarchically to analyze it in detail. It is useful for root cause analysis or drilling down into specific dimensions of data. Okay, so here as you can see I have prepared a very simple explanation here. So here you can see, obviously in the Titanic dataset, first let me explain it for those who are viewing this dataset for the first time. So in Titanic dataset we have information of about 890 passengers. In the data set, we have columns like survived. Survived is a binary value column. Like here, we have two categories like 0 and 1. 0 means not survived, 1 means survived. So after Titanic had an accident, so obviously some of the passengers were able to survive and some of them were not. So this is the output variable, the main variable that we have to analyze. Now on this output, whether the passenger was able to survive or not, there are many input variables or input properties that will affect this output. So, for example, P class, whether the passenger was traveling in first class, second class, or third class, has it any influence on survival rate? Then the gender of the passenger, whether the passenger was male or female, does this variable has any effect on survival? Sibling spouse, parent child. Sibling spouse is how many sibling or spouse was this passenger traveling with, and how many parent or child was this passenger traveling with. This is the amount of fare that this passenger paid. Cabin, whether the passenger received cabin or not. Obviously, this column is something that we can ignore because for most of the passengers we don't have cabin values. Only those passengers who paid a higher price we have cabin values. And embarked. Okay, so embarked is SCNQ, which are station codes, or you can say codes of the port from where people embark to the ship, like Queenstown, Cherbourg, Southampton. So these are the embarked stations. We have done many videos on Titanic exploratory data analysis, and so you can go through those videos first, then then you will understand this more. But after understanding all of this, if you are still trying to understand the drill or the decomposition tree here, so let's get started with it. So first of all, let me explain what is happening here. So the starting node is sum of survived, which is 342. Okay, so out of total passengers, so let's see the simple data. So let's see a donut chart here. We have total of the total passengers will be in passenger ID. Every passenger ID, if you will count passenger ID, count distinct passenger ID and put survived here, okay, in legend. So you will see that the count of passenger who survived, where the survived value is 1, is 342, and the count of passengers who could not survive is 549. Obviously most of them were not able to survive as per this data. So we will start, and our analysis is on those who survived. Okay, like exploring the data of those who survived, like how many male, how many female, and from different passenger class, how many were there, different embarked, how many of them were there. So this is the data. Now for this data, what you have to do, create a decomposition tree. Okay, and in your decomposition tree, first you will get analyze. Now, in our data set, the value is given as a binary value. So we will, when put survived here, it will automatically give us sum of survived. Okay, and this sum of survived means that is 342, the people who survived. Now, so in analyze, you will put whatever variable you want to analyze. Okay, and then in explain by field, you want to break down your analyze matrix by, as you saw here. Okay, so the first thing that we want to break down by is, so let's select this, then is gender. Okay, so here in gender we have two values, okay, male and female. And if you will just drag this to gender and survived, you will see, male and female survival ratio. Obviously here more females survived. Okay, so here in your drill down, you will see a simple plus sign here, so that we will use later. But first we will put gender here. Then these passengers were also traveling in different passenger classes. Okay, so here in legend we will simply drag passenger classes, and you can see in passenger class 1 the percentage of survived people is 39%, 39.77. In passenger class 3, 34, and 25% passenger class 2 out of total people who survived. This is the ratio. Okay, so that's why in our data the second explained by field that we are going to bring is passenger class. Okay, and then after bringing passenger class, we can bring the third column, that is embarked, that is their embarked station code, so which S, C or Q. Okay, so you can simply create another copy of this, and you can see the survival ratio on the basis of three embarked towns. And this is because most of the passengers were traveling from this town only, so that's why this ratio is there. So now we have analyze and explain by. Okay, here if we are taking our mouse over, so you are just seeing sum of survived. Okay, so we can keep it sum of survive or rename for this visual as survived, something like that. Okay, so survived count or whatever you want. In tooltip, we will bring parent and child and bring average of parent and child. So here you will see that on an average, a passenger was traveling with 0.38 parent of child. That is the average, which will give us an indication of in which class, like in which field this parent and child thing is more important. For example, here if you will see some have survived and female. So if you will see female, the average of parent and child and sibling spouse is 0.65 and 0.69. Okay. In case of male, the average is 0.24. That means they were traveling alone, we can say, because they are not traveling with anyone. It's either 0.24 or 0.43. But in case of female, you can see it's either 0.65 or 0.69, which is more towards 1. So that means female were traveling, the probability that a female was traveling with a parent, child, or a sibling spouse is more than in case of a male. Okay. If you see in passenger class 3, so average of sibling or spouse is 0.90 for a female. Okay. For a male, this is again 0.28 or 0.31, 0.2. So in some classes, yes, like here it is higher. So means the female passengers that were there, most of them were traveling with a parent child or a sibling spouse. And most of the females were traveling alone, that we can say. So this is something that we have created here. So similar thing we will create here. So in our, obviously this is something that you can add in your explain by also, but here we are just using tooltips and showing you the use of tooltips also. Okay. And similarly, age is also something that we will bring to tooltips and use average. Like what is the average age in each case? So those people who survived, their average age is 29.62, which is pretty much the average age of all passengers also. And then we will also bring sibling spouse count and use its average. Okay. So now this is our visual, like analyze, survived. In explain by, we have put sex, P class in embarked. In tooltip, we have picked average of parch, average of age, average of SIB, SP or sibling spouse. Now you will see a plus sign here. Okay. When you will choose this plus sign, it will give you three options like high value, low value, or you can select any one of them. Okay. The columns that you selected. So here we will select gender and it will show you both cases in gender or in that categorical column, whatever values are there. So it will give you, it will split the sum into those two variables or those two values. So female is 233, 109. So we can say, obviously, those people who survived, in those people, yes, female were more. Okay. And if you will see, the average age is 28.15 in case of female survived, and average age is 30.42 in male survived. Okay. Similarly, we can click this plus sign, and here what next we want to choose. So we can select P class. Now this is going like this. In survive, female are 233. Out of these 233, what is the breakup? So 91 were survived in the first class, you know, 72 survived in the third class, and 2 in the second class, 70. So from other visuals you can see what is the total count there, and you can select this. Okay. Here you have options like, show items with no data, new group. So right now we are not doing that, but you can do that also. We can click, and you can click on high or low value also. For example, if you will click on high value, so it will show you the highest value. So for survived female first class, these are the high values. Okay. And most of them embarked from S, which is Southampton. And if you will choose male, then in this case high value is 1. Okay. So this is a simple decomposition tree. And so here you can, when you will take your mouse over any bar here, you will see that it will show you all the data, whatever you have put in tooltip and whatever you have put in your explain by. So P class is 1, survived. Sum of survived is 91. Average of parent child in this is 0.46. Like in this class, on an average, they were traveling with these many parent or child, and 0.55 sibling spouse. And average of age in this class is 34.10. So this way you can see different type of values, and you know this is a simple decomposition tree. Obviously you can use it for multiple purposes. This is one of the use. And here I have simply styled it, so you can go to the style part. In your analysis tree connectors, you can select a line color. In your bars colors, you can select positive bar and negative bar color. Okay. And bar background also, if you will use, you will see. So that's why they have selected a very light color, so you can see the highlighted value. In your category labels, You can decide the font color and size. For example, you can see these are the category labels. In your values also, you can increase or decrease the size, the numbers that you are seeing. In your headers, these are the titles, so you can increase or decrease the title. So these are the titles of the all fields that we have included here. And we have not used subtitles. You can change their background also, or as a header, whatever background you want to select, so that it is highlighted. Their color, any color that you want to choose. So these are some settings, and in general you can go to title, enable it, and whatever title you want to put. And if you want to put a subtitle or a divider line, so you can use that also. And one more thing is effect. In effect, you can enable background, visual border, and shadow. So this is something that you can do to create a graph like this. So this was a simple example of decomposition tree in Power BI.